Hello everyone, Happy New Year! Hopefully this will be a year where I'm more productive. See, I'm not done with the Tilemaps series just yet. It's just been going very slowly. I know, very slowly. I'm not one to make excuses, but I have been working on some personal projects I hope to share this year. I hope at some point I'll do a devlog on that to show some of the challenges of making a larger project. And to get back to the topic of this video, I'll be showing you how you can load in some entities into your maps and create a more robust game architecture. Originally, I was going to cover some more subjects like switching maps, but that justifies a whole video of its own, so I'm splitting things up. And without further ado, let's get started. Before we begin though, we need to do some house cleaning. Our code is going to get a little more complicated, so it's important to tidy things up a bit before going forward. Because you see how complicated and cluttered our main file is right now? We need to move some of these helper functions. So I'm going to go ahead and create a new file here called utils.lua, and this is where all our helper functions are going to go, like this create quads right here. We don't need this in main, so I'm going to cut that out, and I'm going to put that there. And then the other thing I want to do is take away this lerp function. I'll put that after there and save that. And we also need to re-include that. So over here at the top, I'm just going to say require utils. And then the other thing we have here are our game assets, like these texture dictionaries right here. So I'm just going to take those out, and I'm going to put them in a new file, and I'm just going to call that resources.lua, and I'm just going to paste those in. And while I'm at it, I might as well take the maps too, because later on we're going to have a whole bunch of maps, or at least more than one map. I'm going to take this. Yeah, I think I could just cut that out right here and put it at the bottom there. And we need to change it so it's not local anymore. Save that. And we'll include resources. Okay. So that should be a lot cleaner. Let's just see if that works still. Okay. Seems to be fine. Alrighty then. Now that everything's cleaned up, let's talk about entities. I'll go back to my map file, and it's going to be pretty much the exact same thing that I did with my walls. So I'm going to add a big table here called entities, and I'm going to parse through the map Lua file and create entities on the fly, just like I'm doing here with my walls. So I might as well just copy and paste this code. And instead of layer 3, it's going to be layer 4. But the problem is we need some actual entities, and what are we going to add to our map? Well, I think I'm going to add the player, of course. Like right now, the player is just a global object, but I want the map to actually have a copy of the player. And one thing to note here is that the map itself doesn't actually need to own the entities. You could have this as a separate data structure. But I think for convenience, like, it works pretty well for a lot of cases to have the entities part of the map. Like if you want to do some kind of level-specific processing on the entities, it's very good for that. So I'll keep it there. But it's totally not necessary. So I want the player and I want a coin. And I've gone ahead and I've actually added a coin texture to this project. So we have that right there. So what do we want to do? Well, we want to actually edit our maps so they have these things. So let's go back to tiled. And here in tiled, well, I have my entities layer. Now, I could do this one of two ways. I could just select an empty right here and add it, and then change the name to player. And that's pretty much all we need, because then we can just check the name to see that it's player. And we already have the X and Y, so that's good. Or we could also use like a tile object, so we have here insert tile. And remember, we have our player right here on the tile sheet, so I could actually add that right here into the the map editor and I could actually see the player. But there's one thing to keep in mind. If I do it this way, the X and Y is actually going to be in the top left corner. Hello, this is a video from future me. Sorry, it's actually the bottom left. The origin point of the tile objects are always going to be the bottom left, not the top. But you can always edit that if you want. If you go to here, edit tile set, and then tile set properties, we have object alignment. And, by default it's unspecified, which is the bottom left, but we can change it to center or top left or whatever, but I'll just leave it at bottom left. Whereas here, it's going to be right where this point is. So either way you do it is up to you. I kind of like being able to see the player, so I'm going to try that out. Oh, we got here flipping. I didn't know that. We have a lot of other properties we could use. We have custom properties, like we can add a direction and things. But for now, that's enough. And then with this one, I'm going to change the name to coin. So that's going to be our coin. And we could actually duplicate that. I'll add in a few different coins. Okay, save. And I'll press Ctrl E to export. Okay, now that we have that, let's check the map file. So if I go here into my city map, yeah, here it is. So here is layer 4, and here's all the stuff we added. We have the coin, we have the player, we got the X and the Y for that, and we got some more coins. So we can just actually check against the object's name. So if you remember, V here in this case is going to be the name, so we can just say if v.name equals player, then what we can do then is we can create a new entity. So what I like to do is I like to go local E, and then I can say E equals player new, and all we really need is the X and Y, so I'll do v.x and v.y, and that's it. We have our player loaded. But the other thing we can do is we can add the coin, so I can do else if v.name equals coin, then equals, well, we don't have a coin object, right? We just have, if you remember, we just have this player, and this player is its own table object. And using the meta tables, we have all of these functions attached to the player. We don't have anything like that for the coin. But here's something I'm going to do. It's a little different from what I've shown in the past with game objects. Rather than create this really complicated data structure, I'm just going to create like a simple table right here. And you probably knew this already, but yeah, this is something you can do in Lua. So I can do x equals v.x, and I can do y equals y.x, and I can also add some more things. Oops, sorry, v.y, and I could do some more things, like I'm gonna do is active equals true. Actually, I want to add that to the player as well, so I'll add it here to the player. I'll just do is active equals true. So this is just something to tell me whether or not the object should be rendered and updated in the map. Let's save that. Okay, now that we have that, what we can do is we can say, like, if E is not equal to nil, then we'll add it to the map. So table.insert, well, in this case, this dot entities and E. So, this is a very simple ad hoc way to just add in entities. And you'll probably want to put all of this in a different function, or better yet, an entity factory, which I might show later. But for now, this is enough just to get something. So we have that, and we need some way to render the entities. So if you remember last time, we have this map render function. I can just put it right here after where I'm rendering all of our tiles. So over here I could just do I, V, and I pairs, self.entities, And there's one thing we should really check before we actually render things. We should say like, well actually I'm going to change this to E. That'll be better. So if E.is active, then, well, we don't have a render function for our coin actually. I just remembered that. The player has a rendered function which actually draws one of the tiles, but our coin does not. So what can we do in this case? Well, you know, once again, I'm just going to hack something in. So I'm actually going to put a render straight into the table. So I'm going to say render equals function. And this is actually how functions work in Lua. They actually are variables that you could assign to things. And when you see a function name, it's actually, you know, this is actually the true form of a function. So I can insert that directly in there, and then, I mean, for now I could just do something like love.graphics.rectangle fill, and, oh, well, we need a self, so I'll put that here, self. Self.x, self.y. Don't forget we have the camera, so we have to say minus gcamera.x minus gcamera.y. Now you might think, oh, this is kind of cumbersome to have to subtract the camera, and it certainly is. I'm going to show a better way to do this later. There's a lot of things you could do to get around that. And then we need a width. Well, this thing doesn't have a width, so I'm just going to add it here. Width equals, what was our tile size again? 64? Okay, 64 and 64. I'll just do self.w, self.height. I think for now that should do. You know, maybe just for visualization, we'll give it a nice yellow color. So love.graphics, second color, red, green, 0 blue, and alpha 1. Okay, save that. Now, hopefully all of that should be rendered. Oh, well, we actually have to call that. So, well, we should always check to see if it actually has a render function. So if e.render, then e.render. Save. Okay, let's see if that works. Okay. Yeah, it's working. You see there's a lot of things wrong here. We've got 2 players in the scene because I forgot to get rid of the global player. But we have our coin boxes here, exactly where I placed them in the tiled editor. Now what we want to do is get rid of that global player and just have the camera follow the one in the map. How do we do that? Like, how do we actually get the player, you know, from the map and send it to the camera? Well, one way that I like to do it is I just like to do something very simple like this, player equals nil. And then when we load the player here, we can just do this dot player equals e. So we can just pass it into the map on load time directly, and that should work. And one more thing we got to do is we need an actual update function. So the map also needs an update function. You remember the camera and the player both have updates. Now the map needs one, so the map is now going to take care of the updating for all of our objects. So function map update delta time, and it's going to be pretty much the same as the render code here. For now, yes, we want to check if it's active, and then we want to check if it has an update. Right now, remember the coin doesn't have an update, so if we don't have this check, it's just going to crash. So I'll pass in delta time. And the nice thing is I'm passing in delta time from this love update into the map, and then the map is passing in delta time to all of our objects. So that's really nice because, you know, if we want to do something like slow down the time, we can do it at a higher level, and then all of the objects will move at the time that we set. So that's one really cool thing you can do with that. Now, how does the camera get the player? Well, that's kind of tricky here because right now the camera is following the player object directly. And, once again, I could just sort of hack this in. So we have our map loaded right here. That means the player is loaded into the map. So what I could actually do is just, this is probably not how you want to do it, but I could just say gmap.player. And of course you want to perform some sort of check to see if there actually is a player. But right now I'm pretty confident there is. The player is set into gplayer and then the camera is following gplayer, so I think that's all well and good, but we want to get rid of this. And we also, we also want to update the map. So I don't suppose it matters where I put this, but yeah, I'll put it here. Gmap update delta time. And we have the map rendering. We don't need the player render anymore. Get rid of that. Okay, so let's run it and see. Oops. Oh, a bit of a delay there. I think maybe the camera is not set properly. Yeah, once again, a bit of a hack. I am just going to set the camera's position to the player directly. So, target X, G camera, target Y, and I'll do the position as well. G camera.x, G camera.y equals G player.x, G player.y, and so on. Hopefully that fixes it. Okay, yeah, that works. I know it's a little bit of a hack there. Maybe one thing you could do is just simply get rid of the camera smoothing. I'm not sure if it's really doing much for our game anyways. I want to respect your time, so I went ahead and loaded in that coin texture. And it's being set to the coin right here, so the texture of the coin is set to the coin in that dictionary. And then it's being drawn instead of the rectangle. So if we look at that, it should look much better. Yeah, much better. But you see, there's a couple problems we have. Well, one, you can see that the player sometimes is in front of the coin, sometimes behind, and also the player is not picking up that coin. Well, to fix the first problem is really easy. That has everything to do with the order in which all the objects are being drawn. So probably the player is being loaded first, and then maybe this coin right here is, or this coin is being loaded first, and then the player, and then these coins are being loaded afterwards. So they're being drawn by their order inside of that entities table. Well, there's a couple ways we can handle that. We can give each object its own draw layer, and then sort the whole table based on the layer value, or we can sort the table based on the Y value. So right now the player has less Y, so the Y value is less than the coin, so he should be drawn first, and anything with a higher Y value should be drawn last. So it should be sorted in the table so that it's higher up in the table, if we think of the table as a stack. Now to do that is very simple. All we have to do is here in our draw function, just before all the objects are being drawn, we just need to do table.sort, and it will be our entities list. And yeah, if you don't know, this is a built-in function in Lua, table sort, and it takes in a table and a sort function. So I definitely recommend reading the documentation on this. Basically, we have another lambda function here. And, what that takes in is like something to compare two objects. So we can return one of the objects based on its value, and then it's going to sort the table that way. We're going to sort it based on the Y value. So if A is, I think it's A is less than B's Y. So if A's Y is less than B's Y, it's going to be higher up in the table. Therefore, it's going to be drawn first. I think that's how that works. Let's just see. I'm going to save that and run it. Okay, yeah. I think that's correct. So right now the players X and Y are a little lower than the coins, but if we go in front, now the Y is greater than the coin, so now the player is being drawn last. And it seems to work that way for all of them now. And it's a really cool effect, especially if you have like NPCs and stuff. Like you can draw the player in front of the NPC and it gives kind of a pseudo three-dimensional effect. Now the next thing of course we got to take care of is the collision detection between the objects, like the player and the coin. This is the part that I've been reluctant to teach because it's a little tricky. But you know, thankfully, like a lot of things with Love2D's physics system, there's some functions built in that can help us with that. I've already explained it in my physics course, but yeah, I'll explain it again and show you how to integrate it with this map system that we have. Before we can register collisions between the player and the coins, we have to add a physics body and collider to the coin. We already have one with the player, which I added last time. So to save a little bit of time here, I'll just paste in some code. So we have here the physics body, the shape. By the way, there was a mistake before. The size is actually 32 by 32 pixels, not 64. And we have here something called a fixture. Now the fixture is actually going to handle the collision. And one thing I'm doing here is I'm using set user data, which by the way I already added to the player right here, and I'm setting it to the entity itself. So set user data is taking in the object itself, and what this is this is going to be data that's passed into the collision callbacks. So this could be anything. This could be a string, this could be a number value. But I'm actually just using the object itself for convenience. And then I'm also setting the coins to set sensor. And what this means is that the player is not going to bounce off the coin. Like if the player touches the coin, you know, the player can just go right through it, which I think is going to be the sort of behavior that we want. But in this case, it doesn't really matter so much. Now, to actually have collisions between the player and the coins, we have to use something called callbacks, which, if you remember from my physics course, a callback is just a function that's called whenever an event happens, and in this case the event is the player touching the coin. So to do that, we actually have to add that manually. So if you remember from before, we have here this gworld. So we can do gworld set callbacks, and this takes in 4 different callback functions. The 4 functions are the begin contact, end contact, pre-solve, and post-solve. And the only one we're going to be concerned with is begin contact. And because I value your time, I'm going to paste in the whole function. So here is our callback function. And for the other ones, I'm going to do an empty function. And I'm just going to do nil and nil. Like, I don't even think I need to enter that. But just for safety, I'll do that. So what's going on here? We're getting a function that takes in an A and a B. Well, what this actually is the fixtures of the objects. You remember we set the fixtures here. We passed in some user data. So that's going to take in the fixtures themselves. And then we're getting the data from those fixtures. And in this case, it's going to be the first entity and the second entity. So it's the 2 entities that are colliding. So first of all, we have to check that we actually have data. And then we have to check if each one has an onCollision function. And this is a function I'm going to create myself. So I'm going to go back here into player. And at the very end here, I'm just going to do function player onCollision. And then it's going to take in another object. And then what I'm going to do is I'm just going to say like if other dot is active, then other dot is active equals false. Like normally you'd want to do something like a tag check, but we're just going to assume that the player has collided with the coin and the coin has an is active, and then that is active is just going to be set to false. So that's effectively going to make the coin disappear. So let's just see if everything is correct here. Yeah, and you probably know that the coin doesn't have an on collision, but that's okay because we're checking to see if it does. So if it doesn't, then nothing is going to happen with the coin. So I'm going to save that. Save that. Let's see if that actually works. And it does not. Oh, I forgot to save the player. I'll save that now. Okay, hopefully now it works. Yep. Isn't that beautiful? We now have coins that react to the player when you touch them. All right. So, as you can imagine, this could be the very start of a fully functioning entity system. I really forgot to explain what an entity is, but the way I like to think about it is an entity is just anything that like moves and has like an update in your game. So things like the environment are all going to be static. So we now have a very flexible entity system. We can edit these things in tiled and then load them into our game. And we can have any kind of entities we want. We can have enemies, we can have a custom update and render function for them. And as you've seen with the coin, we don't even really need a separate file for each entity. It could be something as simple as a function that returns a new table, and then we can set the parameters for the entity inside of that table. So it could be very simple or very complicated like the player. There's a lot we can do here, a lot we've covered today. Next time I want to get into switching maps, and it's going to be a little bit of a challenge because we're dealing with the physics system that, you know, obviously we're going to use an entity to detect if the player's collided with a portal object, but it's not going to be quite so simple because, you know, we can't just delete a map and then switch out a new map from inside of a callback function in the physics system. So there's a lot that I'm going to cover there, but yeah, this thing is almost over. Like there's still a lot of subjects I want to cover in the near future. I still haven't even talked about tiled animations, and you know, another thing I really want to talk about is custom collision detection without the physics system. And I'll try to do better this year. Thanks for tuning in. Thanks for subscribing. See you.